Hello everyone, I'm going to show you how to compile and run the code provided through the paper in order to make the translation from the DataAware declare model towards an atomized one that will be used by the aligner. So in order to do so, you need to go to the source code in here. And then you need to create a build directory. So I already created one, but I'm going to remove it. So rm.rf build. And then you need to also have a data folder. So in the data folder, you have two folders here. One is converted. In the converted, you will need to provide the txt file representation of the declare model as such. For example, let's see one. cat3. So you see after this copyright, then you have this kind of representation of this kind of syntax, because I'm going to parse the file in this way, because the syntax is unique and accepted by a parser actually. And then you need to provide in the cur folder all the logs, just to show you that which are the files in here. You just have the declare model that I'm not going to use, because I'm going to use the model in another syntax. So the syntax provided here is slightly different. I'm going to show you, but this is not the one that I'm interested of. So it's cat3 constraints 0 mode decl. So this is the syntax. So I'm only interested in synthetic representation of these 3 lines in here. So just to show you that beforehand there is no output file in these folders. So to say that everything is done from scratch in order to show the output, so you just create a folder, make directory build, say make ... and that is used to say to the compiler to regenerate everything from this part. And then I'm going to make it in a multi-threaded way. It will take some time. So at this point, then you have everything built inside of here. And then let's go back to the data structure. So just to recap the thing that I stated before, the thing that you will see from here, and if you do find that, is that in the cur folder you have the log files, so in the .xes format, while in the other folder, which is converted, you will need to provide the txt way to provide the declarative DataAware format. So now, if you just go back to the main folder and you run the binary that has been generated, you will see that you have the LTLTF representation, and you also have the notice when actually you're adding the relevant traces for generating a new novel representation of the model. So if you want to, you just take this as the to generate a graph model, because actually the other part of the pipeline takes LTLTF formula in a slightly changed syntax. So you just need to change R into V, and there's straight bar into / to create a V, and then also invert the slashes to create an end and replace the ampersand as such. So even this part will take time because it's going to convert all the log files. I could also show you in the meantime. This is some process already done from before, but anyway. If you go now to the data folder, the thing that you see in cur, in free, for example, in free constraints, and you do find, you see here that you have an atomized representation, an atomized access, and a converted access. So what is the meaning of this? In the converted.access, you have just a relabeling, because the tool that I'm going to use has a different convention for the label name, so I need to convert that into a human readable format. And then you have the human readable format txt, so you just have the sequence of events after the transformation. So you see here the predicates, where beforehand you just had the DataAware predicates, and in here you have the activity names with no conversion, where only the number was replaced. That is just to adhere to different conventions in the pipeline, from the convention on how you need to write the declare model, and also the way that you need to provide the declare model and the log files to the other part of the pipeline. So that is just a renaming, but I'm going to provide also all the mappings for keeping track of the original representation of it. So you see now I'm also shifted to do the 5 constraints. So at this point I should also have the conversion of the model inside converted. And yes, so you have several files. So for the moment there is no doc for the graph file because it's disabled. But you have a free constraint sigma, and then you have equivalent classes. So the thing that you're interested on is actually this file that is actually going to provide you all the equivalence classes between events having the same label. And then you need also the format in the single line, because in here you have the representation of the declare model in different constraints, and you could just reparse that in order to feed this output to the pipeline. And then you have also the sigma file that I'm going to show you now. So the sigma file is actually represented as such, And this is the file actually providing you the conversion and the interval conversion. As you see here, you have the number conversion from up to 10 included, and then the next double after 10, which is 10.0000 and then 2. And then you have actually the maximum infinity represented as in doubles. And similar considerations also for strings. In here you have C3 or C2 that are matched. So in this, or even C1. So in this case you have intervals from the empty string up until C2 and some del characters that here are actually representing the maximum character. Then you have C3 specifically to determine the C3 value, and then you have C3 and the character having the initial number as the minimum values with that question mark up until the maximum string that is in here, for example, of maximum size of 10, but if you have bigger strings you just change the source code to adapt to longer strings if required. And let's see whether in the meantime it has finished. No, in the meantime has finished representing the log file for free, but in a jiffy you will have also 5, 7 and 10. Yet now 5 has finished, and now we are parsing 7. That will take less time because you have less log files. So in addition to that, you will see that only part of the log files are added to generate the whole segment, and that is only because the remainder of the logs actually contain the same event information. And given that this implementation actually does everything as a whole without requiring to rerun the pipeline for each log file, then this implementation is actually taking into account to run everything. But you could also, if you want, to change the source code, and that will be an easy task, to just trim down to loading one single log file and then running on one single model just to provide one single alignment. But that is pretty doable. And now we have a 10th part with the 10th constraints. And so that's it. So this is actually the whole pipeline. You had also the time to see the initial model representation after pushing the negation towards the clauses and towards also the predicates. And then you also see the further decomposition of the model. And in order to link this to actually the initial formula, then you will have all the information inside the data folder. So in the data folder in converted, then you will have all the information about the equivalence clauses that are used to do the replacement actions. You will have a single line clause, so you have the atomized and converted representation of a whole model, and then you will have the sigma just for debugging purposes and also to link back to the data predicates and show how actually the predicates are partitioned. So in this case, you also have the predicate conversion, and as you see here, one single predicate is associated to one single atom, and so that will work. But by the way, the solution has also been tested in other scenarios where you have multiple predicates. So. And then if you go to the car folder, and then you find dot, then you will have that for all the constraints, the atomized.access, which is actually the file required for the second part of the pipeline, have been generated. So if you just check cat, for example, this file, which is actually, for example, free constraints, as to say, so you will see that we completely generated a new access file. And the timestamp is actually the timestamp of when the log file has been generated. So thank you for listening, and we hope that you appreciate our paper.